In this lecture, I will be discussing selection procedures. In particular, looking at the strength of predictors and the methods we use to combine multiple pieces of information about candidates. We've discussed how we have individual differences and that we can use various tests or assessments to get scores to represent those differences. Now, how do we go from those scores to actually choosing someone for the job position? We need to make decisions on which puzzle piece will fit best into our organizational puzzle. Before we move on, there are a few terms I would like to explain. We have significance and we have utility. Statistical significance, that there tells us whether a result happened by chance. There is a very low chance, usually 5% or less, depending on the criteria used, that the result of a study occurred by chance if there was no true underlying relationship. So, if a result is found to be statistically significant, we say it is very unlikely that it happened by chance. Utility is a cost analysis of whether the results make it worth using the selection tool or assessment. So just because a selection tool significantly predicts performance, it may not have a strong prediction, and it may not be worth using because of the cost associated with that selection tool. So we might find a correlation of, say, 0.08, which is not a very strong correlation, but it may be significant with a p-value of less than 0.01. But this may not be big enough of an effect size to make it worth the effort and the cost of using the selection tool. Let's say we have a correlation between our predictor, the individual difference test score on the x-axis, the predictor score here, and our criterion, our outcome of interest, which is generally a job performance score. A correlation can be represented with a scatter plot and a regression line, which is the best fit line going through all the data points. As you may or may not remember from your math classes, the formula for a line is y equals mx plus b. Here, we have y equals 1, which is the intercept, either m or b, depending on which regression equation you're using, 0.5, and this is the slope of the line. It tells you how steep it is. X is the representation of the predictor score. In the process of choosing applicants for employment, unless you have one applicant per job, you have to make a decision. The regression equation gives us some information so we can estimate performance if we know a predictor score. If we know an applicant has received a 4 on their predictor score test, we can plug that into the line. We can plug that into the line equation and see where their expected criterion score would be, their expected performance. In this case, if they have a score of 4, their predicted performance would be 3. And as we go up, you can see that that will increase. As we have a higher score on the predictor, say a 6, the criterion expected level would be a 4. So these predictor scores are individual difference test score. and our criterion score is our job performance. If we create a cutoff for our predictor, we can split this graph in two. You can see that the applicants who are accepted on the higher end of the predictor have a higher average performance, the dashed line on top, than the rejected applicants who have an average performance much lower, the dotted line on the bottom. But as you can tell, this is not perfect. Say our acceptable criterion performance is that of that average level, the solid line in the middle, where it says total applicants. If that's the case, we're going to have some individuals who get a predictor score that is above the cutoff, yet they will not be a success in performance on the job. And likewise, we have some people who are lower on the predictor value than the cutoff, and they have performance above the acceptable performance. So say we have a correlation of 0. The scatter plot of this would look more like this circle rather than an oval. If we develop a predictor cutoff and we pick someone above that cutoff, we have a 50-50 chance of getting an employee who is either successful in performance on the job or unacceptable. So it is not very useful. So here are 3 factors used to determine how and if we should use a selection process. Predictor validity. The more valid the predictor, the better chance of selection giving you the best employee. If a predictor is invalid, there's no point in using it. So that correlation of 0, there is no use in using the predictor with that kind of correlation, with that level of correlation. Creating a predictor cutoff is when we pick a score on the predictor to differentiate between someone who passes and someone who doesn't. We can measure the value of this by comparing the average criterion score, the average performance score, of the selected individuals to the average performance scores of the total group. As validity increases, it is easier to differentiate between applicants, and the higher the utility and value of the test. Selection ratios tell us the selectivity of the hiring process. This is what I discussed when talking about the 4/5 rule and determining if there is adverse impact. In this case, we have the number of applicants who are accepted over the total number of applicants. And this is for the full applicant pool rather than subgroups, which is what we use when determining adverse impact. And the base rate of success. This is the percentage of employees who are performing their job satisfactorily. It is found by looking at current employees. If satisfactory performance can be achieved by just having a warm body in the position, then selection is not going to be too important. If the base rate is extremely high, so meaning that basically everyone does a decent job on the job, then the new selection method won't be very useful. Because our prediction, the validity, is not perfect. There will always be errors in selection. So our criterion cutoff tells us whether performance at a certain level is successful or not. Those above this cutoff are successful. Those below are unsuccessful. If we create a predictor cutoff and we look at whether people above that predictor are successful in performing the job or not, we see what I was talking about earlier, with there being some errors. We accept everyone above the predictor cutoff, and we reject those below it. We don't know ahead who's going to actually perform well on the job. This is an estimated guess using data that we've collected previously. So for the people who were accepted into the position, we see that many of them are what we call true positive. They actually do a good job on the job. And there are also true negatives. Those who did not get accepted into the position also do not. Those who did not get accepted into the position and would not perform well on the job. But we have these mistakes that we made. We have false positives, people who are chosen to be in the job, yet they fail to perform at the level we expect. And we have false negatives, people that we chose not to select, but would have done a good job in the position. So when we use multiple predictors, how do we combine this information? We can do it in a couple different ways. It can be done subjectively, called clinical decision making, using the judgments to combine information, using the judgments of management or those selecting the selection committee to combine information about the relative value of different applicants. This tends to be unreliable and idiosyncratic, maybe biased and lower quality selection choices than what's called objective decision making, also called statistical decision making. This uses a mathematical formula to combine information, and we can do this in a couple different ways. In making selection decisions, we want a selection system that is comprehensive. We want to gather diverse, high-quality information about the candidate. We don't simply want to base something on one piece of information. The information that we collect should predict success on the job. So we need multiple predictors, multiple things that will tell us whether a person will be a good candidate for a job. Selection systems are also generally compensatory, meaning that a person's attribute in one area can be weak if other areas are strong. So maybe someone gets a grade in a course, an individual course, that is not particularly good, but overall, their GPA is higher. Some exceptions to this are physical ability. There are some jobs, like we talked about, with a dancer or a firefighter, that need some minimal level of physical ability. The same is true with some jobs and sensory ability. So we're going to talk about a hurdle system in a little bit. And this is the extent to which we use cutoffs to say someone has to be above a minimum level to become a successful job candidate. So let's look at a comprehensive and compensatory selection procedure. That means we're covering many attributes and we're considering them all. But yet, strength on one thing can compensate for weakness on another. Let's take candidate C, for example. This person has great scores on communication, but much lower scores on experience and cognitive ability. If we look at the total scores, this gives us something we can compare across people. Now, it's possible that we could weight these different factors. Say oral communication is particularly important with the job we're hiring for. We could increase the value of oral communication by multiplying it, say by 2. Say if we feel it's twice as important as everything else, we could make that score 2 times the score that the individuals received in order to total them up. So candidate B here has the highest total score. Yet if you look at it, there is not one individual item that is higher than other candidates. So on the other hand, we could use cutoff scores. These are criterion referenced cutoff. So we look at the desired level of performance that we want in our employees, and we find the test score that corresponds to that level. And we use that as the cutoff. Candidates are required to reach a certain cutoff, and this creates a hurdle. They must get past that point in the selection process to move on. So cutoff scores should be reasonable and consistent with the expectations of acceptable job proficiency. They should include individuals who are capable of learning to perform at a satisfactory level. We want to try to relate predictor scores to specific levels of performance to select the cutoff. This is much harder to do when we only have content validity information instead of criterion-related validity information. In that minimum level, the cutoff score should be based on job analysis. So when we create a hurdle system, an individual has to make a certain score and is not able to compensate for that with scores on something else at a later stage. So this is what we call a non-compensatory strategy. It's often used when there are a large number of candidates for very few positions. Say for graduate school, when a graduate school institutes a hurdle of having a minimum GRE score. In a multiple hurdle system, multiple cutoffs are needed to be met, and they're usually sequential. So if you meet the first step of having a minimum GRE score, then you would move on. When using a multiple hurdle system, it's useful to save the more expensive and time-consuming tests for later. And often this may be something like an in-person interview, where it is very expensive to fly someone or to bring someone in. So the uniform guidelines give us some information on cutoff scores. So where cutoff scores are used, they should normally be set as to be reasonable and consistent with normal expectations of acceptable proficiency within the workplace. So if we look back at our examples here, and we say that cutoffs, we have a cutoff score of 5. So anyone must have a score of 5 or more in all areas. We can eliminate the candidates that have not received a 5. Now look at person C, who when we first looked at it, has the 2 highest scores on oral and written communication, yet was low in these other areas. Here, that person is eliminated from the selection process. So another way to combine scores is through what's called regression. And at the bottom here is a regression equation. We looked at a regression equation earlier with only one predictor. Here you can see we can add multiple predictors and plug in numbers for each of those predictor scores to get an estimated performance on the job. So generally, managers are hiring using more than one piece of information. And we can do this either by using the multiple predictors or the hurdle system that we just discussed, sequential cutoffs of scores. Now, often, many selection systems will use a combination of hurdles and multiple regression. So when we have multiple predictors, the predictability of the full system depends on the predictive power of each predictor and the relationship between them. If predictors are unrelated, they predict separate portions of the criterion. If they are highly related, they predict overlapping amounts of variance. So here we can see a criterion that is predicted independently by two different predictors. So if we look at the areas that are shaded, this is how much of the criterion or how much of performance is being predicted. Here we have two predictors that have the same level, the same strength of relationship with the criterion. However, they overlap in what they are predicting. So written and oral communication are going to predict part of the same, are going to have some similarity in how they predict performance. And that would be demonstrated here by the overlap area of all three circles. As you can see, the unshaded portion of the criterion is much larger here than it was with two predictors that are not related to each other. So when we put this into a multiple regression, when we demonstrate this as a multiple regression equation, it looks like this, with y as the predictor, the slope of each variable, and a is the intercept. So once we've established predictive validity in one population, we want to generalize to another population, so we don't have to conduct another validity study. Based on the idea that there is some true validity. As you can imagine, this is only going to be possible in situations in which the job is similar. Traditionally, research believed you had to do a validity test in a very specific context in which you intended to use it. This is what's called situational specificity. But it's useless to conduct a validity study with very small numbers. And if you have a small company, you don't have the numbers of people coming in as job applicants and as hired individuals to conduct a validity study. It's good for small organizations who don't have enough people to conduct a validation study if we're able to generalize the validity. If you're a large corporation and you're selecting hundreds of thousands of people for a position, it may be better to do a local study because you have the numbers to be able to do that. And it will be easier to argue that your selection procedure is valid for your positions, for your organization, because you have that data. Otherwise, you're having to make the argument that the job you are using the selection information for is similar enough to the jobs that were used for the validation study. In order to argue that similarity, you would need to use job analysis to compare the jobs and show and argue how similar they are. So here is another demonstration of these overlapping relationships. Multiple regression analysis takes into account the correlation, the relationship between the predictor, other predictors, and the criterion. If you have cognitive ability and personality as your predictors, there is not much overlap because they're not very closely related. If you have cognitive ability and technical knowledge, there is some overlap, but there will still be some level of unique prediction for the criterion. Situation C here could be like having two different tests of cognitive ability, predicting criterion. There's a lot of overlap and not much use in using both. So if we're using multiple regression analysis to make predictions of who to hire, we need to do the same evaluation of current employees. We do this because it will give us some information on how we should weight each factor. Like I said, it might be that communication is more important than some other factors, or it may be that technical knowledge is more important. To determine these weights, we look at our current population. But how will we know if this generalizes to applicants? One way we can look at this possibility, one way we can look at this is to do a sampling of our current job. One of the ways to handle this is to look at our current employees and only take a sample of them to get our job weights, to get our predictor weights. And then do a cross-validation using the regression equation developed on the first sample to test the second sample and determine if it fits well. So how do we ensure that we made the correct selection decisions? In evaluating our selection design tools, we need to look at the validity, the accuracy of inferences made based on test or performance data. And there are three different types of validity designs we can use. Criterion-related validity that associates the scores on the predictors with the job performance. We can look at content-related validity or construct-related validity. Criterion-related validity is the best method to use. And this is demonstrated by correlating a test score with a performance measure. We can do this in two ways, either concurrently, looking at the extent to which a test predicts a criterion, that is measured at the same time that the test is conducted. For example, this might be in using our current employees and getting a measure of the predictor we want to use and the performance, and seeing how closely related they are. We could also do a predictive study, which gives us the extent to which test scores obtained at one point in time predict criteria obtained in the future. And this would be more similar to the selection procedure, because when we're asking candidates to fill out tests or to do interviews, we are getting information on the predictors at time point 1. Once they are hired into the job position, then we later get performance information. So the Uniform Guidelines, as you remember, is a document written by the EEOC for employers to have information on what is acceptable and not in terms of their selection procedures. So as you can see here, the acceptable types of validity studies include criterion-related validity studies, content validity studies, or construct validity studies. And a criterion validity study should consist of empirical data demonstrating that a selection procedure is predictive of or significantly correlated with important elements of job performance. If we are using criterion-related validity evidence from sources other than the employer who will be using it for the specific job they will be using it, then we need to be able to show job similarity. How closely related is the job that was used for the validation study and that which they will be using it? Here is an example of what high or low validity would look like in terms of ranking of employees and comparing the cognitive ability score to the job performance. You see, in the high validity situation, people remain pretty much in the same order. With low validity, it's all over the board. There's not the ability to predict who is going to be a high job performer based on where their cognitive ability score is. And this is the whole point of having predictors for our selection procedure, is to have ones that tell us how people are going to do on the job. So in creating a validation study, we need to determine a number of things. Who will be in the study? Will this be current employees, job applicants, similar employees, maybe at in another corporation? Will it be people in the same type of industry or somewhere else? And how many people will we use for the study? What measures of predictors and performance will we be using? And when will we be measuring each of these constructs? Will it be concurrently, looking at predictors at the same time as job performance? Or will we collect information on predictors at a time before we measure job performance? I've put a link here for a very good example of creating and validating a selection process. And in it is an explanation of various steps in the process. So in conducting a validation study, the employer should consider available alternatives, which will achieve the legitimate business purpose with lesser adverse impact. If there's a predictor, test, or assessment that we want to use that has known differences for subgroups of people, but yet is job related and gives us important information about potential performance on the job, we will want to look at our system and see what we can do about minimizing the adverse impact that it may create. The EEOC or court could ask an employer why an alternative procedure with less adverse impact and similar validity could not have been used. So going back to the utility of a selection system, remember, utility is the economic value of making personnel decisions. And it's important to look at the selection costs, both in terms of time and money. We need to show how personnel practices contribute to the overall organization. Sometimes it's less obvious here than it is with other departments within an organization. We can combine information on assessments of worth of a good performer, of the validity of testing. The higher validity, the more utility it will have. The cost to administer tests. If the cost to administer tests is very high, it's going to be harder to argue the utility. But there are also costs associated with how long people will be in the organization, so the tenure of new hires. And how valid is the current system? If the current system is not very effective, if it does not have a high validity, then instituting a new system may be worth it. We can also include things into this utility analysis that include things like reduced the level of turnover, how much training will be needed. If we are hiring people that have higher credentials coming in, we may not need to spend as much on training. What about safety issues? Are we reducing the amount of accidents that may occur if we are hiring people, if we are using our desired selection system? And will there be higher job satisfaction for the employees that we hire? Using an appropriate and valid selection system could have an estimated savings for a single organization of millions for 1 year, depending on the size of the organization, etc. Another consideration in a selection system is that it often may be the case that you don't hire the top people that are identified by your system, that you'll have to move down the list and take the second or third or fourth choice of your job candidates. So the complexity and subjectivity of utility makes some people skeptical. But it helps sell HR practices. Many managers require a lot of convincing to put stock in these numbers. And something else I want to mention before we're finished here is placement. This is assigning individuals to jobs after they've been accepted into the organization. This most often happens in very large organizations, such as the military. So candidates are accepted and hired but then we need to determine where they go. There are various strategies that can be used for placement. So a vocational guidance strategy would be based on what individuals want or preferences. This is not always practical in organizations. So this would be allowing students to choose a major. They have an interest in a certain thing, and they place themselves into the major. This could also be done using vocational interests or matching of skills to particular job positions. There's pure selection based on organizational needs. Only the best qualified get placed into a job. But then the question becomes, what happens to the lower applicants that are not placed? And there are successive selection placement strategies in which we fill all the jobs with people who are minimally qualified. And then on top of that, we consider the individual's talents and preferences.